Welcome to another Geometry Nodes tutorial. In this one we will be making a rope bridge. I just want to go ahead and say a huge thank you to Jacob from Inlight VFX for kind of challenging me to make this. Really fun little exercise and also very useful, so definitely go check out his channel, linked in the description down below. So working in 3.0 alpha, make sure that you're in 3.0 alpha or higher, right, if 3 has been released. And let's jump into Geometry Nodes. So first of all, we need to add an object to contain our bridge. So let's just rename this one to rope bridge. And let's create a Geometry Nodes tree in here. And again, I will call this one rope bridge. Now, the reason that I'm naming the Geometry Nodes tree itself is because this is going to be a tool that you can use to append to other scenes where you need a Geometry Nodes, where you need a procedural rope bridge or something similar. So when you append this, you will append this as rope bridge, or you can right click on stuff and mark it as an asset. And then when you use the asset browser within Blender, you'll be able to pick up the rope bridge asset and it will be a procedural bridge making tool. If you're interested in the rope bridge that we will make today, then I will leave a link down in the description to a Gumroad listing. I will share it on Gumroad. Cool. Okay, so rope bridge. First things first, I do not need the plane. What we're going to be doing is we're going to be creating a parabola. At the moment, there are no curve primitive nodes that will allow us to do this conveniently. So we're just going to do it the longhand method, which is still very easy. So let's grab a line node. I've got my shortcuts on the 3D viewport there. So right now we just have a line. We need to do a bunch of stuff to it. So the way that we can draw a curve, the way that we're going to be doing it is with 2 control points like so. And from these 2, which we will use empties for, we're going to create a sort of a midpoint that we are going to pull down, right? So we're going to create a third point. Now, to make a parabola, the best way is basically to create a line like this, create a line like this, and then from each point, we can basically connect it. So if you think of this as being cut into a few points like so, if I was to connect each one of these, so 0 to 0, 1 goes to 1, 2 goes to 2, 3 goes to 3, 4 goes to 4, and you can see that you're starting to get that kind of curve shape in there. This is logically the process that we will be going through, but very simply, we will just be using mixed nodes. So we get our line so that we can get an index. So let's just do that. Attribute separate XYZ. Come in here like this, and we're going to take our position and we're going to output index. And then I want to convert this into a factor. So let's also just grab a math node, attribute math node, and we want to divide our index. Going to output fact here, and we're going to output this, divide this by a float value, which needs to be the count -1. So let's just bring in a value node here, connect this and this, and you can see if I have this not -1, then our fact doesn't actually reach 1. So that's why we need to add the utility math node to this, and so let's do subtract 1. And there we go. Now you can see our fact values go from 0 all the way up to 1 properly, which means that we can use it as a value range, as a factor range for our mix factors. So that's super important. Also, this count will automatically read our inputs as an integer because it's an integer socket. And so just to make sure nothing gets out of sync, let's floor this one here, and that will do the same as make it an integer, essentially. So this will always remain 0 to 1. The next thing I want to do is actually add my endpoint. So I need some empties. Add an empty sphere. Let's just grab 2 of these, come back to our bridge, and I will drag these in directly. And we need to set both of these to relative. So that just makes sure that everything is being compared against the origin of our object, even when we move our object, right? These 2 points, I need to take the average of them to get the middle, and then I need to subtract something from the Z to make it move down a little bit. Vector math node, add these 2 together, so join and join, and then I want to scale this by 0.5 because we have 2 inputs, so divide by 2. It's faster, computationally faster to scale by 0.5 than to divide by 2, so always use multiplication if possible. So now what I need to do is actually subtract something from the Z, subtract, and I'm going to use a vector combine XYZ and another input value node. So this now becomes my my sag value. There we go. I rename this one to sag, recolor it, just so I don't lose track of what's going where. So now I have my point A, which is the start of my bridge, my point B, which is the middle of my bridge, and my point C, which is the end of my bridge. Now we can do the fun part, which is actually make our curve. So with the help of an attribute mix node, we can actually do this quite quickly. Need to make a little bit more space. The nodes we're really interested in here. So an attribute mix is going to change my factor to an attribute, and we're going to use the fac attribute that we calculated. And the reason for this is that basically each point along this needs a different value. Basically, it needs to be mapped to a different part of the interpolation. So if I was to now grab two vectors, and I was to go from point A to my midpoint B, well, if I write this to position, then you'll see that we're going from one end here to our sag, sorry, for the center point. If I change my sag value, then it moves down, and it's pointing as well straight towards the other empty. So you can kind of get an idea of what's going on there. If I add another one, and this time we're going to go from the middle to the end, like so, then you can see what's going on there. Now we have the first, A to B, and we have B to C. So I'm actually just going to rename these ones AB, BC. And then we need a third mix, which is going to take the fac again. It's very important. And we're going to change these to attributes this time, AB, BC, position. And there we go. Now what we have is simply a curve. This an original value node here allows us to control the resolution of this first sort of iteration of our curve. So we're going to be tweaking it and using it for a whole bunch of different things, but this is like our initial curve that we use. The next thing I want to do is I want to actually create some planks. So let's add a new collection. Let's call it planks. And I definitely recommend that you use collections to instance things. Even if you only end up using one object, it's just as easy to set it up in a collection. But it does give you the opportunity to use multiple objects. So in the case of the planks here, I might make 5 or 6 different planks, and they'll all have different textures, different states of decay. And it basically just makes it a little bit easier to work with. Something which I'm going to do a few times here when I make something is I'm going to make sure it has a kind of a relevant dimension. So for planks, that would be the width of 1 meter or just over 1 meter. It basically means that when I later on multiply or change the scale of my instance, the amount that I'm changing it by kind of makes sense in real world scale. I've just added a cube. Let's change the dimensions of this. So we're going to go 1.1, so just over 1 in the x. In y, we're going to go 0.2, and in z, we're going to go 0.04. There we go. So now we have this nice little plank. Apply rotation and scale, that's always important. And I can hide that collection. Going back up to our rope bridge, let's just instance that. So point instance, collection, turn off whole collection. There we go, doing those planks. So right now, it doesn't look great. And that is because they don't point in the right direction. You know, if we go to top view and I move these around, it's not really doing anything useful for us. And also they don't follow the direction of the curve. There's two things that I want to be able to do, but how do we go about doing it? Well, we do now have some curve nodes which will help us. So the one that we want actually is curve to points, but right now we have a mesh object, right? This attribute mix is outputting a mesh object, as we can see in the outliner, so in the spreadsheet. So I need to convert it to a curve so I can convert it to the points. I know it's a little bit confusing, but let's just do that. So grab a curve, mesh to curve, and then we can do a curve to points. So now it's just points. And this one's great because we can change it from count to evaluated, which uses the original points from the input curve. Count is evenly spaced and gives you the certain number that you choose, or the one that we want is length. And this is because well, we have a certain number of planks. I know they're 200 mil wide, so I want 300 mil centers. So there's a bit of a gap in between, right? So I can just set the length in between each point to be 0.3. So now if we look at the point instance, wow, it's much better. So this already sorts out a lot of our rotational issues. However, we do still have some other rotational issues, right? It's pointing up in the middle. So you've got to do some rotation. Now, another thing that this curve to points node does is it outputs a whole load of additional curve-based evaluation. So this is like our analytical node for curves, and it will output radius, tilt, resolution, tangent, normal, and rotation. And this is super important because we want the tangent. So the tangent is basically if you have a circle like this empty, the tangent is like the line that comes past it here, right? We want to align our planks to the tangent of the curve. So point, align rotation to vector. They're pointing in the y direction to the attribute tangent. And there we go. That is how you can align very quickly things to the curve. And as well, everything is still working swimmingly. So the planks are not finished, but we will be coming back to them a little bit later. Control J, planks. Now the next thing I want to work on is the ropes, and we're going to be making a bunch of ropes. Basically just a few things that we need to do to make sure that when we make them, it makes sense what we're doing. First thing I want to do is I want to make sure that if I just join these two together, so I have my curve at the bottom and the planks on top. If I move my curve with a transform, so I want to move it horizontally on here, right? So I want to move it in the X direction, is that correct? No, this transform is moving it in the world X. If our bridge is rotated, then it just doesn't work. It just doesn't work, basically. So we actually need to be moving it specifically perpendicular to the bridge. And there is actually a way for us to do this without too much trouble. If we basically find where our empties were, and I'm just going to take this add node, Control Shift D to duplicate it with the inputs, and I'm going to change it to subtract. So now this vector math node will be the direction and magnitude, so the vector from one point to another. And I then want to do a little bit of maths. So let's take a separate XYZ, a combine XYZ, and I want to plug my X into the Y, my Y into the X. So that's the first thing. And then I want to grab a utility math node. And on the X here, I want to multiply this by -1. I'm trying to think of a good way to explain why I'm doing this. If I just add a plane, okay, so we have two lines which we know to be at right angles to one another. This one on the left, this one goes across not very much. So this is our X, and it goes up by a lot, right? Now we know these two sides are exactly the same, so these triangles should be the same, right? So this one goes a lot along like this and then down. So this is the important factor. Our Y becomes our Y, right? So this is positive going in this direction, and this one is in positive going in this direction as well. And our X positive going in this direction. However, when it becomes this side over here, you can see it's actually going in a negative direction. I don't know if that explains it very well, but essentially this is how you can find the perpendicular vector quite easily with maths without doing too much like computational stuff. We're basically just taking the inverse of the X becomes Y, and just the Y becomes X. So now what I can do is I can plug this into my translation. I mean, we have another issue that we need to solve here because it basically is the same distance away as our empties are, but it is at least moving perpendicular and remaining perpendicular to our bridge object. So what we want to do first of all is we want to normalize the vector, which means to give it a magnitude of 1. And there's a function for this. It's just called normalize. It's quite simple. So now our vector has a size of 1, regardless of how big or small this is. So that's fixed that problem. And then I also want to scale this. And if I scale this, then you can see that that actually changes the distance. Let's add another input value, call this one width. So this is why I made sure that the planks had a 1 meter horizontal distance, because when I set up my width here, you can see that I'll be able to change the scale of the planks according to my width, and it will make sense. So for a width of 1, I only actually need to translate this by 0.5. It's just that there will be another one going 0.5 in the other direction. So if I want my width to be 1, then I actually need to half, or times by 0.5 my width value before it goes into that scale. So something like this is fine. Just Control H on that transform node just to collapse it. Control Shift D to duplicate. And I'm going to take another scale node, join those up like that, set my scale to -1. So this is going to invert, and this is going to be my vector for the top one. The bottom one inverted becomes the vector for the top one. Super useful just because it means that I have one control for my width and it fixes both of them. There we go. So now you can see we have a rope on both sides, or at least we have a curve on both sides. And let's just remove the planks for now, just while we're working on this. Next thing I want to do is I want to make some sort of ragtag ropes that are hanging down, looking a little bit dilapidated. So I'm just going to take this join geometry, which is both my sides, and I'm going to add an attribute randomize. I'm going to add a vector to the position. And we're going from -0.1 to positive 0.1. So it's not like a significant distance, but it is enough to make it look like there's a second rope there. I'm just going to increase the number on here up to something like 32. That's probably fine. And this just means that there's enough kind of resolution going on. I want to make sure that my minimum Z is a little bit lower just to make it look like it's hanging. And I'm going to make my positive Z just a bit higher as well. Something like that looks pretty good to me. I'm literally just going to duplicate this down so it's exactly the same. And I'm going to change the seed. So now you can see we have a few. And then I'm also just going to subdivide this to make it smoother. So mesh, subdivision surface, and just give it a few of those. And that looks much better. Cool. Okay, next up, handrails or hand ropes, I suppose I should say. Going to take the same clean ropes here. And we're just going to add an attribute vector math node. Going to chuck this on here, and I'm just going to literally add a vector to the Z height. Vector combine X, Y, Z. I'm not looking at the X or the Y, I'm just doing the Zs. So I can take another one of these, hand height. Let's call it hand for now. This goes into the Z, and normal height for handrails is 900 millimeters. And if it's like a balcony edge, then it would be like 1.1 meter. So I'm just going to go with 1.1 because it's a bridge. You don't want people falling off it. I'm just going to join this on to here as well. So these are just the hands. So now we have the top and the bottom. And what I want is some little zigzags to join these together. Now in an ideal world, and indeed the future world, we would just take the bottom points from our bottom rope, top points from our hand rope, and use these as start end points for line segments. However, with geometry nodes in its current state, this is not possible. So we're going to do something a little bit ingenious. I'm going to take our clean ropes once again. And if you've watched my bricks tutorial, if you've watched the herringbone tutorial or the fabric tutorial, then you'll have seen me do this a few times. We're going to modulate at 2 and then greater than 1. Are we? No, we're only going to modulate at 2. So you would use a greater than 1 if you're using gradients, as we do often in shaders. However, in this case, because we can use the index, which is going to give us every alternate point, we can literally just set this to be modulating at 2, because then it'll just be 0, 1, 0, 1, 0, 1. And then we can use it with a mix, use it as a mix factor. Probably easier if I just show you. So we're going to take the index output to, let's call this one alt for alternating, float 2. So modulating at 2. And if I come across to where this is, we can see that we have alt 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, and so on. So we can now use this as the factor. So attribute mix. We basically want to be doing the same as we were before. So if I add my handrail height to the position, so position, output position, and B is going to be a factor, which is literally just the same, literally the same one that I used before. So now you can see if I change my factor between 0 and 1, we go from foot height to hand height, which is great. However, if we don't set this to a constant, if we set it instead to an attribute like alt, now you get zigzags, where the first one is at foot height, the second one is at hand height, and so on. Great. I do not want to plug this into here because it will get subdivided and we don't want that. I would just like this to be joined afterwards. Now we have all of our ropes. Next thing that we need to do is actually just add a profile. So again, this is thanks to our new curve nodes. We can just go curve, mesh to curve, curve, curve to mesh. However, when we come back to being a mesh, we can add a profile curve. So in this case, I'm just going to add a mesh primitive circle, and it's tempting to just add this directly and just be like, oh, I don't understand why this circle doesn't work, but it's because this is a mesh object. When we get curve primitive nodes, then it will, you would just use the curve primitive node instead of the mesh primitive. Okay, let's go back into solid view. Gonna reduce this down to 8 just to make sure it's a little bit neater, and ropes are around about 1 inch across for a thick rope, so 0.025, and there we go. So this is looking pretty good so far. However, these zigzags you can see are super narrow, and this is quite simply just because there's a circle at the top there, and there's a circle at the bottom there, and this like diagonal, because of the way it's being skewed, it's super narrow. So what we want to do is actually we want to subdivide the mesh so that we get some circles that are sort of perpendicular to it down its length, like so. Not subdivision surface, because that will actually change where the points are. We just want to do a mesh subdivide and drop that on here, so you can see that's already a bit better. 3 or 4 is fine depending on how neat you want it. So another really cool thing that we can do now is actually add knots. Completely optional, of course, doesn't matter if you do this or not, depends whether you're going to be close to the object or not. or not, let's add a new collection for knots. And I would recommend, if you don't already have it enabled, turn on the Add Mesh Extra Objects add-on. This is a super useful add-on, gives you a bunch of stuff like torus objects. So we can add a torus knot, and this is pretty cool. However, it doesn't have a lot of settings. So you can change the resolution and you can change knot types. Oh, some of these are very fancy. I'm just going to go with this first one, the 3. All we have is location and rotation. So for some of you, you might be thinking, wow, well, this is way too thin. But we can just go into edit mode here and go Alt S, and this will allow you to scale it up. Something like that, maybe even a bit more. And then I might just subdivide like that and smooth. Great. Let's make it a lot smaller. So I've rotated it to upright as well, and I'm just putting it on there. So let's disable this collection now. All I want to do is I would like to instance these knots. So add a point instance node, and we're going to instance it on before that subdivide on our zigzag. So basically it's going to be at the bottom, and then at the top, and then at the bottom, and then at the top, and so on. So collection, turn off whole collection, do the knots. So that's looking pretty promising. As we rotate this, the knots don't rotate with the bridge as standard. We know how to make them rotate because it's what we did with the planks. So let's take our mesh to curve, curve to points, and align rotation. And I'm literally just going to duplicate it, Shift D, Alt P to remove from the frame, bring it up here, and I'm going to just stick it in before the instance like that. Now, way too many knots. Why has this happened? It's because our length here, or sorry, our curve to points is being evaluated on length, and we just want it to be on the original evaluated points of the actual mesh. So now it looks like it's all tied together nicely. Cool. Let's just add a quick bit of randomization to those knots. So attribute randomize, just going to leave it as a float, set this to scale, and we're going from 0.8 to 1.2. 0.8, 1. Just gives us a little bit of variation on that. Let's frame this, Control J, knots. Let's go back to our planks for now. We've got a few things that we need to do to them. First things first is I want to do some rotation and some scaling, just to basically add some randomization here. So after our align rotation stuff and taking into account the width of our boards. So the first thing I want to do, basically attribute fill, let's make a scale attribute here. Going to set this one to vector. Going to call this one scale, and let's add a vector, combine XYZ just on here. So let's set these all to 1 to begin with. And then the X is our width, is that right? Yeah. So we can just set our width value in here, into here, like so. And now you can see as we increase the width, we also increase the width of our planks, which is super useful. And then what I want to do is I actually want to randomize the scale. So I want to take another attribute, randomize, and I'm going to change this one to vector, change it to scale, and instead of replace create, we're going to set this to add. Generally, if I'm doing scale, I will have it set to add instead of multiply. So we want to be adding between -0.2 to +0.2. Looking pretty good so far. And then the next thing I want to do is randomize the rotation. So I'm literally just going to take rotation, and again we've got this set to add, so it's not changing, it's not like redefining the rotation. You can see as we rotate this around it's still working correctly, but this is also too much. So let's go -0.1 to +0.1 in all axes, and that just gives it a little bit of danger. Feels like it's falling to pieces. More things we want to do. More. I want to remove random boards. That's the first thing, just to make it feel like it's really falling to pieces. So let's add a attribute randomize. We're going to create a random number. I'm going to just call this one missing because it's, you know, missing boards. Literally just a value 0 to 1 for each board. And then we're going to go attribute compare, and we're taking missing, finding out when it's greater than a float, and we output this one to missing again. And then let's use a point separate node. Geometry 2, importantly, geometry 2. Set this to missing, and now you can see if I increase the amount that are missing between 0 and 1, we get more or less boards missing. If this was a bridge, which it is, it would need to be tied to something at the ends. At the moment, these hand ropes are just floating in space. Obviously kind of problematic because there's physics in real life. So let's make sure that we have some space for piers, right? So there's going to be a block here, and a block here, right at the end. And currently we have a board at each end, so I want to remove the first and the last board. We've already done a lot of stuff to our bridge. However, we still have things like the index and the factor, and I know that my first board has a factor of 0 and my final board has a factor of 1, which means that we can basically just say where does it equal either 0 or 1 and then separate those points. Don't put boards there. So it sounds maybe a little bit complex, but let's just throw this together. I'm just going to do attribute compare, and we're going to say where does it equal, so where does the factor, the fac attribute, equal 0.5. You might be like, why 0.5 is not 0 or 1, but we have this threshold. So if I set my threshold to 0.499, then it basically means that anything with anything which is outside the range of 0.001 to 0.999, anything outside that range is going to be a 0. So let's just chuck it like this. And there we go. No more first or last boards. And now we can use this same method to sort out our Piers. So let's make another collection here. There we go. And I'm going to be adding just a placeholder for this one. So just like I did with the planks, I'm going to make sure that we are starting with a height of 1, right? So that I know that my scale, when I set my hand height, I can basically just multiply my Piers by the height of the handrails, and that will work accordingly. Just give me a little bit of buffer. I'm also going to make sure that my top is a little bit higher. For example, if I have a hand height of like 1.5, I don't want the top of my pier to be exactly where the rope goes into it. I want it to be like 1.6 or 1.7 or something. And then equally for the bottoms, if you've ever played a game where you see a tree on a steep slope and you can like see the bottom of the asset. So just make sure you drop this down a little bit and it will help. It will just make sure that if you're on rough ground with your bridge piers are going to stay in the ground basically. So it now just looks like a bit of a pier. At the end of this video, I'll do like a proper scene and I will make actual planks and piers and things. So these are just placeholders for now. But yeah, importantly, make sure it's 1 meter. Going back to our rope bridge, looking pretty cool so far. I want to find the ends of the side ropes. So we can take our clean ropes here and we can literally take our attribute compare and point separate node here, Shift D, Alt P, that just brings it out of the frame. Join this up like this. Now we can have a look. Geometry 1 is our endpoints. That's literally all we need. We can just grab a point instance, collection, whole collection, turn off. Set this to piers. You have yourself some lovely piers. There is still actually a little issue here. You may be able to expect what's going to happen. If I rotate this around, the position of our piers moves, but the piers themselves do not rotate. So I'm literally just duplicating these nodes. So curve to mesh, curve to points, align rotation to vector, Shift D, Alt P, and we need to put this before the point separate because it won't be useful as a mesh. It won't have any tangent information. And I have a little issue. Half of the rotation is fixed because we can now move these around. However, the piers fall over. That's not the sign of a strong bridge. We need actually another align rotation, because if I change any of these, it actually just confuses it. And if I try to like lock the Z axis, it also breaks. So let's just take another align rotation to axes, to vector, sorry. And we're going to take the Z. I'm just going to leave my pivot. I'm going to set my vector to a vector, and literally just 001 is fine for that because these will now point straight up and they will rotate properly. So we fixed the pointing up in the Z direction and we've fixed the X and Y rotation as well. Now we can sort out the scaling. So these always need to be the same height as the handrail. So let's make sure that we have our scaling going on. So let's grab an attribute fill node and we'll set this to scale, change float to vector. And we're just going to grab a vector, combine X, Y, Z, plug this in like so. And where are our hand heights? Hands are over here. So this goes into our Z axis like this. X and Y gets 1. So now you can see if I change my handrail height, these get stretched in the Z axis. You can see the bottom's going down. That's just because we did that extension below. X and Y is 1. Z is hand height. And the next thing is we're going to randomize it. So let's add a random vector, -0.2 to +0.2. There we go. That's just enough to get things a little bit more interesting. And then I'm just going to give this a tiny little bit of rotation as well. So add to the rotation And we're not going to do much to this actually. So very small, minus 0.05 to 0.05. Just gives it a little bit of freedom. There we go. So this is the Piers completed. Let's just group all of these together, frame them up. Control J. Okay, so how's this all looking together? Pretty good. Is there anything else we still need to add? Yes, there is. There's one more thing that I want to make sure we address, and that is this stretching. So while we get enough boards in the middle, enough planks, our stretching here is actually caused by our original inputs. So I need to make sure that this gets proper treatment. And to do this, what we need to do is control this value by the distance in between my two empties. Nice and easy to do. Let's just grab these, leave those points where they were, and let's grab a vector math node here, distance, and I can plug this into here and into here. It's still a little bit wide. I think what I'm going to do actually, so these zigzags should really be per board, I think, or maybe per two boards. So what I'm going to do is I'm going to, if I set this to divide, right, so if I divide my distance by a smaller value, you get a higher points, right? So if you divide by 0.5, it's like doubling it. And the reason I'm using divide here instead of just multiplying is because this is now my distance in between points. And what this means is I can come in over here where I'm setting the distance in between my boards, and I can set this with a value. So input value node, set this up like so, 0.3 was what we were going with. And I can also bring this up here, drop it in to that divide. And this just makes sure that we have every other board is supported by one of these zigzagging ropes. Spacing, there we go. And let's make that red just so I know to come back to it when we do our grouping. So, I mean, this is more or less done. You know, this is like the bridge. There is actually one more thing that we need to add to the nodes just before we do the group inputs, and that is materials. So let's just make a material for the ropes, because everything else, all of the planks and the piers and the knots, they're going to bring their own materials as instances, and the rope is actually being generated by the node tree. So you can see I've just put a material on here, material ropes, and nada, nothing's changed. So let's come up to our ropes, which is this section here, and I'm going to add a new material assign node, change that to ropes, and there you go. That has fixed all of our rope problems. Now we just need to go around with our group input and make sure that we're connecting stuff up in a useful manner. So let's make a little bit of space so you can see the modifier here. We want this to be a tool that is useful and reusable, importantly. First up, let's remove our geometry input. Just don't like having extras. And I'm going to plug these into our empties. So let's rename these start and end. Let's just start off with here with this for spacing. So let's go 0.3 in here. Join this up, and let's rename this one spacing. Next, let's hit sag. There we go. After the sag, I'm going to add the width and the hand height. So width, and I might just move this one up a little bit here, up in the stack. So width is going to be from default value of 2, minimum of 0 up to maximum of infinity, just depends whatever you want. Next one's going to be the height here, so let's join this one up. There we go. Default is going to be 1 and minimum is going to be 0. What other controls do we need? Well, we have these missing ones, and this missing range for our bridges, these go from 0 to 1, so we only really need a slider for this. So let's grab a slider off our align rotation node and then remove that because we don't actually want to be selecting that align rotation, we just want the slider. Now we're going to connect that up to my greater than here. Set this to missing planks. And you know, you could add loads of things for like the randomization amount or anything you want to change. You can set up your system to do that. Oh, of course, so we need all of our collections, right? So this one, we've got a collection for planks. We have our collection for piers, and we have our collection for knots, and finally our rope material. We need to stick a random seed on the front. So there's a lot of stuff which actually needs connecting up to a random seed. And I'm literally just going to find everything that I can that has a random seed, and I'm going to connect it. Starting at the top, we have this point instance. for our collection, and we also have an attribute randomize, so let's join both of these up. And we have 2 attribute randomizers here. These ones are a bit special because these ones do our kind of scratchy ropes underneath. So I need these to have a different seed. If they're the same, then it looks like only one rope. So I'm literally just going to go in here and add a random value. So we've got our attribute randomize for the Piers. We've got 2 of these. So let's connect these up to the seed as well as the actual point instance itself. And on our bottom row here, join up our randomized nodes and the seed on the point instance. There we are. Last one. We have finally got a bridge, and I can set this and it makes everything a little bit cool, a little bit jaunty. So if I want to make a second bridge, I can just select everything and duplicate it anywhere, right? I can move things around because it's separate. I can change the sag on this one. I can change the seed, I can set how many planks it has, and I can even, if I just duplicate the bridge and one end, I can make it so that the original end stays the same. So let's shift D, and you can see that it has maintained that one middle connection. So that's pretty cool, huh? You could do a lot of stuff with this. Awesome. Okay, so for the rest of this video, I'm just gonna make a scene and see if I can do some cute stuff, make some proper planks and knots and piers and things, and actually texture it as well, stick in some shaders. But it's just a demonstration from here on out. Check the links in the description if you're interested in getting this as a tool, like my finished one, once I've done a bit more to it. And hopefully this was fun. Hopefully you learned something. Enjoy playing with geometry nodes. There's so much more that we can do with it than we've already seen. And the devs are hard at work making all of these new tools and nodes. So check it out. Make sure you've got the latest builds. I'll see you later. Have fun and enjoy geometry nodes.